Hey everyone, good morning. My name is Norbert, and I'm going to talk about network design considerations for different protocols who are looking to use ZKPs. A little bit of background from me. Most recent research I've been involved in was Ethereum Protocol Fellowship research program with two other fellows on ZK prover models, where we were looking into the selection methods and incentive models of ZK provers. And we created a proposal for STEX, request for proposal for decentralized prover coordination. And then most recently, I received a research grant from Aura Protocol and made a research on node coordination and network design for them, and created a proposal also for how the network design for a ZK Oracle could look like. So Aura Protocol is an on-chain AI protocol and ZK Oracle network, and that's going to be my case study. Current work, I'm research contributor at Aura Protocol, doing protocol research at Gevulot Network, and research contributor also for Zero Computing. So some initial thoughts. There are very different protocols that are looking to implement ZKPs in their setups, and they have very different proving demands and also proof frequency that they require. Stateless protocols, for example, such as ZK oracles or coprocessors, or we could name a whole lot, they can have different proof demands and proving frequency because, for example, a verifiable on-chain data feed would need a proof every Ethereum block. On the other hand, a verifiable automation task would only need a proof generated upon the trigger condition being met. Or there could be, again, ad hoc requests as well, ad hoc jobs. While for stateful protocols like ZK rollups, the dynamics of proving is actually driven by the block production workflow. Regardless of the differences, there are the challenges faced and the guarantees required by all these protocols are actually pretty similar. I listed here a couple of them and what we are looking at when designing a protocol, and that's what I'm gonna try to break down in my case study as well, is to make sure we can check as many of these as possible. So some basic design questions for any dual node protocol. Could be a ZK Oracle, could be a ZK rollup. So to separate or to merge, that would be the first one. Do we want to build or do we want to create two network participants, or merge the two roles into one role and simplify the network through that? For ZK rollups, it would look like sequencer prover separation, which is similar to proposer builder separation for Ethereum. And yeah, that's an important thing as a starting point. Also, to enshrine or not to enshrine, do we want to use an in-protocol prover network and build it from scratch, or do we want to implement an out-of-protocol proving mechanism? And actually, yeah, so the trade-offs are external dependency versus higher compute efficiency with the out-of-protocol proof markets. On the other hand, very important is to consider what is the cost of the higher compute efficiency. Because if we sacrifice decentralization, proof markets being a bit more susceptible to centralization, then yeah, we need to design carefully. And also regarding L2s or ZK rollups, I think Togrul from Scroll's been talking about this quite a lot last year. Do we need sequencers at all? If block building is going to be outsourced anyway to specialized builders, similarly to how it's working on Ethereum, then how about provers directly working with the builders? But again, it poses other questions and challenges regarding consensus among provers, etc. The key design areas of my research are basically listed here, and these are the ones I'm going to go through in my case study. But just quickly, network participation, what monetary requirements, what capacity verification, what entry and exit criteria are there, workload distribution and prover selection. So do we want a competition or a competitive environment, or more a cooperative one? where parallel proving and multiple parties being rewarded for their work is incorporated. How much redundancy is optimal, and what kind of backup mechanism should we have there if we want to lower compute waste and lower redundancy? From the economic side, it's like reasonable user fees on the one hand, sufficient node incentives and also penalties on the other hand, and obviously tokenomics are very important aspects. I like rating systems. I know many people don't, but I do think that a properly designed, verifiable, maybe even cross-chain rating system could be just as important and valuable like the stake or any monetary requirement someone may deposit or provide. Or I would go even further, in the long run, it could even be more valuable. But so, do we need a reputation system at all? And what kind of approach do we want to use? Staking-based, earning-based rating, or performance-based rating? How do we manage risks? And at last but not least, how do we measure network health? I think like putting theory into numbers, quantifying certain aspects of the design is really important to get transparent information out and to have certain metrics to follow the network health. I created with two other fellows I've been working with at the EPF, we created a couple of metrics as optimization problems. Like for decentralization, we could be looking to minimize resource distribution inequality, be it related to CPU or RAM concentration, or be it related to stake concentration. We could look to maximize, for example, a metric like geographic diversity. Regarding liveness, I think a reputation score, either for validators or the provers they are nodes or the provers they are interacting with, I think it could be important to maximize, and uptime and a certain reliability index could be included in there. And regarding censorship resistance, I've been thinking quite a lot about maximizing like a non-censorship index, which could be per prover or per node, per validator, taking into account the total censored jobs and applying some kind of censorship penalty, and thus decreasing the overall index of the certain node or prover. And then whoever is interacting with the protocol, they could know, or they could even have this incorporated in their selection mechanisms. So going further to the case study, I'm looking to present a proposal I made for Aura protocol. Again, it's an on-chain AI oracle and a ZK oracle network. There could be two main node types. One of them is a standard node, the other one is a prover node. The former one requiring less hardware capacity. It's fetching data, executing custom logic around that, ensuring that a proof is generated on top of data and computation correctness, and also submitting that ZKP to L1. While the provers would be actually the ones generating the proofs with more substantial hardware, including GPUs, etc. And vertical integration is something I think is very important. Also, STEC, Tyco, and some other rollups are using this in their or looking to use this in their architecture. So any standard node who is also acting as a prover node would be able to vertically integrate and do the proving themselves whenever they are selected for a job. So some requirements for network participation: there should definitely be some kind of monetary deposit for the standard nodes, not for the prover nodes per se, but there will be something else mentioned on another slide for them. So some kind of deposit in native tokens to be made for standard nodes to ensure good faith, Sybil protection, etc. And there have to be some kind of entry and exit mechanisms also to control free riding, to control mass exit. I think it's important. apologies if we cannot go too deep in some of these due to the lack of the time, but I'm trying to give a high-level overview on what it would look. However, for provers, there could be a capacity verification, or there should be a capacity verification actually, upon initially joining the network, to verify that the prover is indeed able to generate those proofs and perform the jobs assigned. And there could be periodic random hardware capacity checks and activity checks as well, like POW type of proving job with some time constraints assigned to the provers randomly, so that they prove they are still capable and available to be actively participating in the network. The node selection I propose should be based on a verifiable random function. A set of standard nodes being selected for some L1 slots, like 10 slots, or could be one epoch, and they perform all the jobs for all ZK standards, ZK Oracle standards. The standard nodes would need to sign a commitment that would be a confirmation of their availability, and that could also serve as a means for early detection of unavailability if they don't sign the commitment or don't return the commitment. And to make job distribution fairer, I would exclude any node who's been selected twice consecutively by the selection algorithm. I would exclude that node from the next round to give space to the others. For job distribution, I think it's important to assign proportionally to the node's initial deposit to make sure that sufficient economic security is there for all the, like, behind all the jobs they are assigned and they are performing. And related to redundancy, I think that's a tricky question, and I think it's a very interesting one. Do we want a fixed redundancy defined by the protocol, like finding a balance between sufficient liveness guarantees and minimizing resource waste? So there could be 3 or could be 5 nodes selected for each and every job, and then they compete, so to say, among each other. Or there could be customizable redundancy, user-defined. They could consider their priorities, whether it's costs, whether it's liveness. Less redundancy would mean lower fees, higher redundancy, obviously higher liveness guarantees, but also higher fees. So these type of things are, I think, very important as well, and hence part of my proposal for Aura protocol. I'm sorry, I went the other way. Related to proof generation, ZK Oracle node, like standard nodes, are responsible for generating the proofs. They could have 2 options. If vertically integrated, they could do self-proving. I think that could even be the default option. But they could also outsource proof generation that could go through like out-of-protocol relays similar to MEVBoost, to PBS. And it's highly likely that such out-of-protocol relays would emerge. For example, STEX Proof Boost is in the works, I think already or starting now, which actually serves the purpose of facilitating this type of negotiation between nodes, in STEX case, the sequencer, and out-of-protocol proof markets or proving networks. Also, the prover has to sign a commitment, submit it to Ethereum, and include the prover bond. So as opposed to the standard nodes locking up a certain deposit continuously, provers would just provide a bond as and when assigned a job. And this is returned upon successful delivery, but also allows for slashing. And yeah, the next one I think would be backup mechanisms in case of node failure. I feel it's really important to differentiate between an ad hoc one, where any node for some reason cannot deliver. And then I think in my proposal, we would open up the job to the whole network, so any node can jump in and complete the job. While in case of an extended network failure, like significant drop in available active nodes in the network, etc., the whole network could go into backup mode, and all jobs could be performed based on an open race, and until balance is reached, and then the original mechanism could be reinstated. A little bit about economics. In my proposal, I propose to implement a bounty mechanism for users. That's what we've been talking around with Aura protocol as well. And I propose a minimum bounty balance from which any fees related to the user's queries could be deducted. The bounty rewards would cover normal stuff like transaction gas costs, call data, or soon blob fees, some gas overhead for communication between standard nodes and the registry contract. But more importantly, it would also include a service premium, which could be percentage-based, could be fixed. More research is needed around what would be the optimal way to address this. And it's also very related to tokenomics and how much subsidy is needed in the initial phases until proving costs get lower, until user demand for these types of ZK Oracle services increase drastically. Regarding who defines the bounty rewards, it could be user-defined, but I think that's suitable more for the testnet because it would then look similar to a reverse auction. And for that, the whole design would need to be rethought. But also, I propose for a mainnet, for example, a protocol-defined bounty reward, which gives a whole lot of flexibility. And if combined with customizable redundancy, it still gives the users the chance to customize their costs or to adjust their costs as per their needs or their priorities. Network-facing economics on a high level, so node incentives would consist of bounty rewards paid by users and network rewards. I think subsidized by the protocol, but this should be decreasing over time, similarly to how some other protocols are in the process of doing this. The reward distribution, though, is a very interesting aspect, in my opinion, as well. I propose a reward curve for the standard nodes. Let's say there is a fixed redundancy, 3 nodes competing for each job. Based on the reward curve, all 3 who complete the job within the time window would be actually rewarded. First one getting the most, last one getting the smallest rewards. But this would enable a more balanced distribution of rewards, and potentially more node operators and higher decentralization could be reached through that as well. Prover rewards in that sense are kind of out of the scope of the protocol itself, because as it's the responsibility of the standard nodes to get the jobs proven, they settle the payments with the provers directly. And I think last slide, regarding penalties and slashing, I think uptime failure, job completion failure, and censoring or front running could be those cases where we apply penalties. Certain, like job completion, I think is job completion failure, one of the key aspects. It could be based on a base penalty. In case of ad hoc failure, it's the base penalty that is applied. In case of recurring failure, the penalty is multiplied by the number of failures or failing instances. And there would be or should be a forced removal from the active node set below 50% of the original state deposit if the deposit of the node drops below that. Censoring and front running, since it's a ZK Oracle network, I think it's important to also incorporate something along those lines. And for node rating, node uptime and job completion rate should be, I think, the basis for a rating system for standard Oracle nodes. And something like a prover reliability index could serve the basis for a rating system for prover nodes. And I think we are reaching the time. Sorry for being so long. Thanks a lot for your attention. And we can discuss any questions offline. Thank you.